Hello everyone. So today my topic is transmission frequency. So transmission frequency refer to the specific frequency at which a signal is transmitted in the communication system. It plays a crucial role in determining how signal propagate, interact with the environment, and are received by different devices. The concept is fundamental to all forms of wireless communication, from radio and television broadcasting to mobile network, satellite communication, and beyond. So, here is the detailed aspect of transmission frequency. So, we have several aspects. First one is a definition and important. Number two is frequency range and band. Number three, transmission frequency application. Number four is modulation technique. Number five, propagation characteristic. Number six, regulator consideration. And the last one is challenge and consideration. So we will talk detail each item. So first one is a definition and important. So transmission frequency, the frequency at which carrier wave is modulated with the data for transmission over medium like the air, space, or cable. Important. The choice of transmission frequency affects signal strength, range, data rate, and interference with the other signal. It is critical in determining the effectiveness and efficiency of a communication system. So here is frequency, range, and band. In transmission frequency are divided into various bands within the electromagnetic spectrum. Each should to different application. It from the low frequency from 30 kilohertz to 300 kilohertz. This one is for low frequency. And for medium frequency from 300 kilohertz to 3 megahertz. And high frequency it's from 3 megahertz to 30 megahertz. And for very high frequency, the range is 30 megahertz to 300 megahertz. And for ultra high frequency, the range is from 300 megahertz to 3 gigahertz. For super high frequency, the range frequency is from 3 gigahertz to 30 gigahertz. And the last one is extremely high frequency. It's from 30 gigahertz to 300 gigahertz. Okay, next is transmission frequency application. So these different frequency bands are allocated for specific use, minimize interference and optimize communication. So here are the application like the radio communication. For example, AM radio. It is suitable for long distance communication, but is more susceptible to the noise. And FM radio provide a better sound quality and less affected by noise. television broadcasting. These bands are used for for analog and digital TV broadcasting, and also offer better propagation over long distance, which support high bandwidth essential for digital broadcasting. And for the mobile communication, 2G, 3G network operation in various band within a UHF range, typically between 300 megahertz to 2.6 gigahertz. The frequency support voice, text, and service, which high frequency provisioning fast data rate. And for the 5G network, it uses sub 6 gigahertz band, and the range is from 600 megahertz to 6 gigahertz. And millimeter wave band 24 gigahertz to 40 gigahertz. And for high speed and low latency mobile broadband. So point D is satellite communication. So satellite communication, it has first one is L-band, used for GPS satellite phone and some mobile satellite service. And they use L-band frequency from 1 gigahertz to 2 gigahertz. And Ku band frequency from 12 gigahertz to 18 gigahertz. And K band from 26 gigahertz to 40 gigahertz. And used for satellite TV, high-speed satellite internet, and military communication. And point E is Wi-Fi. Wi-Fi use the 2.4 G band, commonly used is for home and office Wi-Fi network, and offer a good balance between range and data rate. And 5G band used for newer Wi-Fi standard, and providing higher data rate, but it's short range. And F.S is Bluetooth. Bluetooth, the band is 2.4 gigahertz. Bluetooth operate in 2.4 gigahertz band, and designed for short range communication between devices like headphone, keyboard, and LOT device. And the last one, G radar system. So radar system also have 8 band. It operate between 8 gigahertz to 12 gigahertz, and used for weather monitoring, air traffic control, and marine radar. And for the L-band radar, operation between 1 gigahertz to 2 gigahertz, and it's used for long range surveillance and air traffic control. And we know is we also have the modulation technique. So we have learned it before. So just a quick introduction. For AM amplitude, the amplitude of carrier wave is varies in proportion of data signal used in AM radio broadcasting. And frequency modulation, the frequency of carrier wave is varied according to the data signal used in FM radio broadcasting and some mobile application. Phase modulation. The phase of carrier wave is changed according to the data signal. PM is often used in digital communication. So now we continue with the propagation. So propagation, we have the low frequency. This frequency can travel long distance, particularly over water, and penetrate the ground. They are ideal for long range communication but offer low data rate. And for the high frequency, these frequency are better for line of fire communication and widely used in broadcasting, mobile network, and satellite communication. And microwave and millimeter wave, this higher frequency offer high bandwidth and data rate, suitable for applications like satellite communication and 5G network, but they are more susceptible to attenuation by abstract call and atomic condition. Atmospheric condition. So for come to the regulatory consideration. So we have the 2 points to talk here. One is the spectrum allocation. Spectrum allocation, government and international regulatory body like the Federal Communication Commission in the US and International Telecommunication Union manage the allocation of frequency band to prevent interference and ensure that efficient use of the spectrum. And the last one is licensing. Many frequency bands require license for use, particularly those used for broadcasting, mobile communication, and satellite service. So the last one is challenge and consideration. There are 3 points here we are talking. First one, interference. Transmission frequency must be carefully managed to avoid interference with the other signal. This is particularly important in densely popular area where many devices may be operate in the same frequency band. So point number 2, frequency reuse. In cellular network, the same frequency band can be reused in different geography area, increase the capacity of network. And the last point is signal attenuation. Higher frequency generally suffer greater attenuation, especially through obstacle like burning and folic requiring more careful planning of transmission power and attenuation antenna replacement. So come to the summary. So transmission frequency is the crucial factor in the design and operation of communication system, influencing everything from the range and quality of a signal to the type of antenna required and the potential for interference. Different frequency bands are suited to different applications. From long-range AM radio broadcast to high-speed 5G mobile network and precise GPS signal, understanding the property and use of this frequency help in designing effective communication system that meet specific need of various application. So that's all for frequency transmission. Thank you.